Before we work this interesting problem, let's work an example of the floor function. Okay, let's do the floor of 22 over 5. Now, the floor function is often called the greatest integer function. It's the greatest integer less than the input argument. And just the plain English of that means this is equal to 4. Okay, it's the greatest integer that's less than 22 over 5, which would be 20 over 5, which is 4. But notice, if you want to look at this definition here, that's because 4 is less than or equal to 22 over 5. Is less than 5. And that's just the formal definition. Most of the time you don't really need it. Less than 5 right there. Okay. So you see, that's an example of just utilizing this definition, even though you don't really need it if you know what the greatest integer function means. Again, it's called the floor function, but it was in the old days called the greatest integer function. Now we're looking for all, it'll be positive x in this case, such that the floor of the cubed root of x times x is equal to 488. Now one thing that's kind of useful to note at the very beginning here is 488 has, well, I guess we could have waited on this, but what, 2 times 244 is one factorization. Now if you do it, if you take another 2 away, you get 4 times 122. Right, and both of these factorizations, that there's others, right? You could have 8 times what, 61 also, okay? But these factorizations kind of come into play. So let's move along. Now, we are dealing with the floor of the cubed root of x. Now notice if we replaced x with the cubed root of x and then cubed both sides, we just end up with this statement right here. In other words, our x could have been, we could have taken x to be the cube. I mean, the input argument could have been the cubed root of x, right? That just flat out, that's the input argument. And so you can see that it would go, you would have k less than or equal to the cube root of x less than or equal to k plus 1. But to make it, to get it to be x, something we can work with, we have to cube both sides. So that's where this cube comes from, here and here. Okay, and again, this is just immediately substituting this in right up here. Okay. Okay, now let's move along and see if we can work with that. Okay, let's take a look at the first. And another thing to note is the floor functions, this is the cube root of a positive number, and you're taking its floor. It's certainly going to be bigger than x when x is, let's say, greater than 1, I think, for all positive x, basically, right? So let's go ahead and try out what would happen for 2 times 244. Now that forces 2 to be right here. But you see, notice that, in other words, that forces 2 to be equal to this, okay? But notice that that would happen, and I'll just write this out, on the interval 1 to 2 cubed, right? Or no, wait a minute, that's not right. It would happen on the interval 2 cubed. Sorry, let me erase this. It would happen on the interval 2 cubed to 3 cubed, right? Any number, folks, and what I mean by this interval right here, any number 2 cubed, any number between 2 cubed and 3 cubed, right, would have a floor of 2 based on this definition up here, right? Okay, but this number is not in this not in this interval, right? In other words, 244 is not in this set. 244 is not a member of this interval, folks. Hope that makes sense. Again, this is 2 cubed, which is 8, and this 3 cubed is what, 27? Okay, So that's not going to work. You see, that's not going to work. 244 is too big to have a floor of 2, right? Okay, so now let's look at the other definition. Okay, I mean the other factorization. We also have 4 times 22. Okay, so we have 4 times 122. Okay. Now notice off to the side here, 122 is in the interval from 3, what is it, 3 to the 4th. It's in the interval from 3 to the 4th, which is 81, right? To 3 to the 5th. And this probably should really be a closed bracket here, but it's not important as far as this the way this goes. So you see, folks, this is 81, and this is 243, right? So you see how our 122 is in this interval, okay? So you see everything is satisfied right here. This would be, for this choice, I'll just write it out down here, you would have the floor of the cubed root of 122, okay, times 122, right, folks? But remember, we've just shown that this is 4. This is equal to 4 times 122. Which is equal to the 488, right? It's equal to this 488 up here, right? Equal to 488. So you see, we found the solution here. The solution is 122, okay? X equals to 122. Now, there is another factorization, but this function is an increasing function. And so you can check 8 and 61 if you want, but it doesn't work, okay? So you can verify that, but the only answer I got for this, folks, was X equals to 122, okay? Now, I didn't rigorously prove it, but this is an increasing function. By the way, it's discontinuous, but it's a nice looking function. It's a linear, more or less, on intervals, and then there's jumps at the integers, okay? But X equals 122 is the only solution I found. Okay, that's all.